Now they can hear you talk, and they can see us.
Woohoo.
Good. And I'm going to handle the chat on my left.
How many streamers do you get usually?
How many people are usually in our channel? Viewers are usually range from 20 to 80.
Oh, that's a lot.
Yeah. So, and I have about 1,700, a little over 1,700 followers.
Mm-hmm. And
So-
then they can watch it later, or it doesn't
Yep,
say.
it records it to video on demand, and that stays on Twitch for 2 months because I have Amazon Prime, and then I archive them onto YouTube. So everything that comes through the channel then
Eventually.
goes on. Yeah, so they can go to YouTube if they have something in particular they want to see. Like, what were we looking at Halloween? We can find out. So, this is useful. So we are streaming.
Right now?
Yeah.
Okay.
And you might want to tell them, what we're looking at, who you are, what we're doing. There's probably not a lot of people in the channel yet.
Okay, so we're looking at June Lake's samples, diatom samples, and this one's Dr. Stone.
They can't see me very well because I'm off of the screen.
And I'm Laura, and I'm a master's student at the Paleolimnology lab here. And that's all I have for now.
That's fine. Good enough. Enough of an introduction. And we will probably be streaming from 1 until, well, my plan is at least 3.
Okay.
But you said you had something. I didn't read the whole email. I just you have something
like
in the
getting
lab?
ready for the
Okay.
presentation. So we're
You have a
meeting
presentation at 4:30?
4.
Oh, it's at 4.
Mhm,
Okay.
4.
For your microfossils class.
Yes.
So like 3:30 you need to cut out, or 3 o'clock?
Yeah, we agreed on 3.
Okay.
So
Okay. Well, I can either take over control or we can just stop then.
okay.
Either way. We'll see what the crowd is like here by that point. Yeah, I haven't shown up in the menu yet, so
Is this one Gyro Sigma? Gyro Sigma?
Gyro Sigma. or
Gyro
Gyro
Sigma?
I say Gyro Sigma
Gyro Sigma?
because I'm American and that's how we pronounce it. Gyro. When you go to the Greek restaurants and they give you the meat,
That's a gyro.
here in Indiana they either say gyro, hero, or gyro.
Okay.
And it's like a bit of a controversy how you say it.
Yes, because 3 ways, that's a lot.
Yeah. How would you say it?
Maybe gyro?
Gyro? Classic?
Yes.
Yeah. Pacific Plankton is here. My friend Pacific Plankton says
Hi,
good
Pacific
morning.
Plankton.
The microphone's there.
Hi, Pacific Plankton.
It doesn't help to talk to my computer, and also the camera's up there, so we are doing science, and Laura is currently looking at. What are you looking at?
Gyros, gyro Sigma?
Gyrosigma, correct.
Gyrosigma from June Lake. Is this one a navicula, the one that's there as well? I'm not sure.
Yep, that's Navicula oblonga. It's the one of the very large naviculoids. So, and it has more or less parallel sides and broadly rounded ends.
Mm-hmm.
And that's usually
How you can tell?
how you can get it to species. So the genus is Navicula, and oblonga is in a sort of subset of other diatoms that are similar size and shape
Mm-hmm.
in the western U.S. So it's like oblonga, aurora, and I think there's like 2 or 3 other ones that are kind of in that group where they're really large, have broadly rounded ends like that, and like might be mistaken for Pinularia.
Yes, because they're very big.
Yeah, they're almost Pinularia size, up to like I think maybe 200 microns, some of them in length.
Because this one's navicula also, right?
Yeah, I think that's also a Navicula.
But it's really
yeah,
small.
Yeah, they range in size quite a bit. So.
Like that? Do we know the species? Gyrosigma.
I don't remember the species for this one. It's one of 2 that are really common in the U.S. It's probably a tenuatum.
Mm-hmm.
But let me look, and I'll tell you how you can tell the difference, and then we can zoom in on it.
Okay.
Zoom in on the actual like structure.
Like in the center?
Yeah, in the middle. And so the normal 2 that I usually see, that we see in North America regularly, are a tenuatum and a cumulatum.
That's the one I was thinking, but because I don't know the other one,
So if you look at them, here they are. This is a cumulatum, and this is a tenuatum.
Mm-hmm.
And they are pretty similar, although I would argue.
But yes.
This is.
Oops.
No,
it's
all right.
touchscreen.
Yeah, it's touchscreen. So if you look closely, actually, we don't have SEM images of this on here. But if you go to the website and look, it'll tell you the characteristics, and there's also an option to compare. So if you're trying to do the identification and you click compare, it will tell you the cumulatum is smaller in size and more slender. The cumulatum also has longitudinal and transverse stria that are equally spaced. So if you were confusing it with something, and then you could look at that, and then so we're looking at the description for a tenuatum, right?
Mm-hmm.
So a cumulatum is smaller in size and more slender.
That means it's
But you'd
not
have
as
to, you'd have to
curvy?
s- Yeah,
Or what
you'd have to
does
see.
slender?
Slender means like the width is not.
It's not as fat, or
It sounds fat. Yes.
Okay.
And so you could also look at the shape. So if we zoom out now and look,
I clicked this one.
that's
Does
okay.
that do something?
No.
Okay.
You're all right. So this one isn't very curvy, right?
Yeah,
It looks
no.
almost parallel. And if you go back to the main page where it shows all of the species, a cumulatum is a little bit more curvy,
Mm-hmm.
and I think that a tenuatum is a little bit more straight. And so if I
So
were to
that's what
guess,
we're dealing with?
I would guess this is a tenuatum. Would you agree?
I think so, because this one is definitely, like, the apices go,
Even stronger.
yes.
Yeah, they're a little bit more like.
And the center part for this one is like oval, and like
Mhm.
how do you how would you say something that dorso ventrally like
Compressed.
compressed? So it's like, yes.
Yeah, it's a little bit more compressed. And I would think this is probably attenuatum. We could look and see what Laura called it. Laura Strive called it.
I
in her
have
counts.
those, so I can
And she might have
compare
had
it.
both. They're common epipelic diatoms.
Mm-hmm.
So for people who don't know what epipelic means, that is diatoms that live on mud surfaces. And it's a benthic diatom, so it lives on the bottom, but these ones in particular live in muddy substrates. And so they're common in lakes. And we usually find one or both of those, but you can usually tell by how curvy it was. And I'm pretty sure when you asked me what species, I said attenuatum.
Yes.
And my brain just does this thing where it remembers species and the details of the species without me thinking about it. So I have a funny story about yesterday. You probably need to zoom in on that to really see the detail.
Do I want to zoom in on this part?
If you want to take a picture of it.
Yes, I do.
Okay. I mean, there's probably better examples of that in the sample, but just so that you can kind of see the detail of the striae. And then I would get those in focus and then zoom back out if you wanted to take that picture. So get in, pretty close so you can make sure that it's completely in focus. And this one
Maybe
also
this
looks like
one.
Yeah, there you go.
Yes, because I'm not entirely confident with navicula,
Okay.
so I
Yeah.
think I
Who is?
need a little bit of practice. No. I think
Good.
the
So, as you know, we have a microscope at home, and Carlin's been working on analyzing some samples from Marl Lake.
which one is, where is it?
I think it's in Iowa or Wisconsin, one or the other. I don't know. Someplace out a little bit west of here. She was showing me some of her stuff and asking me what species I thought it was, and we were having a little discussion about what it could be. And she showed me something, and she's like, "What is this?" And I was like, "It's Placanese." And she couldn't remember the name Placanese because she hasn't looked at, analyzed diatoms for a long time, so
Mhm.
she'd forgotten which genus it was. She knows Placanese, she just
Mhm.
forgot, the name. And she goes, "Yeah, but what species?" And I was like, "I've never seen that diatom before, but I think it's Explanata." And
Was it?
She went and looked through the books, and it was Explanata. And I have never had that diatom in a sample before, and I haven't looked at the Placanese in Cromer and Longobertolo, which is the book she was using,
Yes.
for 15 years. And just off the top of my head, spit out
The correct
the right
one.
species. And she looked through all of them, and she's like, "I think it's this one." And then she ultimately came to the conclusion it was the one that I had spit out, which was Explanata. And I was like, I don't know how that happens. I can't explain it. My brain just goes, "I know this one," and it goes and gets the information and then just spits it out my mouth. So,
Well, that's a good superpower.
it
so.
is. If you want to be a diatomist, being able to just recall species and their characteristics from 15 years ago in a book you haven't looked in for 15 years, that's a pretty cool superpower. So, let's see. We do have some comments. I spell fast, yes, Pacific. Have you guys separated happiness diatoms yet? I'm not sure what a happiness diatom is.
Me either.
We don't know what that means, Macallion. This is what ducks eat. Oh, like duckweed. You mean like lemnicola, maybe? Or, ducks eat duckweed for the most part. There's all kinds of diatoms that live on duckweed, but I don't know which one you mean by happiness diatom. Kerbal wants to know, how do you even focus the SEM? So,
It's quite the process.
before the stream started for 15 minutes, we were working on getting the details of the focus correct. But for the most part, the SEM is focused by a little knob on a console on the desk up here. And I don't know.
Can you actually
Can you
move
lift it
the-
up, or you can move the camera down and show them?
This one?
Yeah, yeah.
Which one's better? I don't want to.
It doesn't matter, I don't think. So, yeah, that's the panel that we use to control it, and that's the magnification, and the one that says WD is the focus. And the reason it says WD is because that is the working distance, and what that really means is in order to focus the SEM, what you do is make micro adjustments to the height of the SEM. And if you look in the little window under Laura's head, you also have the camera, so it's like this
I
right
don't
now.
know.
You can put it down just a little bit. Yeah.
There?
Yeah, that's good.
Okay.
It's pretty good. Perfect. I just thought you were a floating head, so
Oops.
when you make an adjustment to it, you have to make another adjustment. So if you look at the little chamber in the camera that's under Laura's head, there's a window that shows you all the samples that we're actually looking at, and then there's like a metal cone coming down from the top, which is the pull piece, which is where the electron beam is being fired down. And when she makes changes to the focus, what she's really doing is moving that carousel, which is the metal part below all of the stubs, up and down, just really, really tiny amounts, like really milled, super tiny amounts. And that part is moving up and down, which actually focuses the beam on different parts of the specimen. So it's done by changing the height of the sample. And when we switch to something else on the stage, it's at a different elevation, so it goes out of focus. And then, like if it was at exactly the same height, it would still be in focus. But most of the things are three-dimensional, and so they have different elevations, and so that means that the image will be out of focus until we adjust the height a little bit.
What's this one?
Kalathon's the Diatom Whisperer. What is that one?
It's definitely a girdle view of something.
It's definitely a girdle view.
I don't know. I'm thinking maybe one of these Starosiras or...
It's in the Starosira, Starosirella, Pseudostarosira group.
Yes, but
then what?
I think that's all I have. I think we can... I don't know.
So, can we tell anything else about it?
I don't know if these little spines are characteristic or something.
So from the side, it's actually really hard to tell these groups apart between Starosira, Pseudostarosira, and Starosirella. And there's another one that it could be, which is Pseudostarosirellopsis.
Oh, okay. I don't know
so,
that
like,
one.
The names are crazy,
Yes.
but they are just telling you the same thing, that they're all little tiny fragilarioid diatoms that are
Okay.
colonial. And the one thing I think you can tell, I'm not totally convinced because we haven't let the beam get through all the way through the sample, but it seems to me that there's a little bit of a three-dimensionality to it. Like, right
So-
where the beam starts, it looks
Uh-huh.
like it's a little bit wider to me, and it looks like it's going slightly into the screen and then
Mhm.
coming back out of the screen and then coming back into the screen at the bottom. So
That would mean it's the diamond-shaped
it
one?
has like two knobs
Mhm.
on the mid parts that are a little bit wider than the rest of the diatom. So this is something we could do easily in a light microscope, or if this thing were slightly at an angle. But if you look right here, you see how this is got like a little bit of it in focus,
Mhm.
and then it goes out of focus, and then it comes back into focus here. So this suggests to me that the outline of this thing is got double humps.
This one?
Nope, not quite. So I need a
Taking
picture.
a
I need to
picture.
draw an image. So the shape of it, in my mind, as a result of that, is like this.
Ah, okay. Yes.
And what we see is this and this are in focus.
And then the
And
deeper
there's a
parts
dip in
are-
the middle and a
Mhm.
dip towards the outside edges.
Mhm.
And so that actually is a clue for which this thing...
I'm showing them because they don't know.
Right. So that's what it would probably look like if we were looking at it from above.
Mhm.
And so if we went to go look through the different things it could be, and then look for that shape, I think that is a pseudostar Osira.
Yes.
I'm gonna double check before I make a definite determination. Yeah, I like this one right
Yes.
here. So if I had to guess, this is where I would put it, which is pseudostar Osira robusta. This one. And there's actually some pictures in here where you can
In
see the
girdle
hump in
view.
girdle view.
Mhm.
Would you agree with my assessment?
I think so.
So I will share that. That's what I think the species is.
Maybe we can find another one that's on bulb view.
Yeah, and that's exactly what I would recommend. There's two things we could do. If this was the only thing that we found in the sample like this, which is highly unlikely because these are colonial and they're probably all over the stub, I would say we could tilt the stage.
And make it a little bit.
We could actually turn the stage up underneath so that it's at an angle, and then we'd be able to see it from the side. So that's one thing that's really different about an SEM that you don't get with a light microscope. Light microscopes, everything's mounted. You're stuck with it the way it is. In SEM, you can actually tilt the base below, and then you can see things from the side. I would argue we probably don't need to do that.
But if we needed to, then we
But
can
if this
do
were
it.
like if we thought it was a new species and we wanted to get
Every
a
single
view
angle
of
of
the
it.
side or whatever, we could actually tilt it. So.
That's very nice.
An eider duck eats shellfish. Yeah. It looks like pastry to you.
This one?
It would be a delicious pastry, probably.
I mean, pastry is pretty good.
Yeah, any pastries.
Yes.
We'll take them. We will consume them. Sorry, my sketches.
So this one is Pseudostyrosyra robusta.
I believe so.
Pseudostyrosyra
You like the robusta?
robusta.
Robusta.
Robusta, yes, in Spanish.
Which means?
Like,
Sturdy.
yes.
Yeah. Robust.
Uh-huh.
Husky. It's a husky diatom.
Is it though? It's pretty small.
I don't know why they give them names like that. I guess because the holes are small and a lot of the diatom is solid silica. Maybe that's where it got its name from. We could go back and look. This diatom was named by Fusey. So that's probably quite old. "20 minutes behind chat." We do what we want with chat, so try to keep up, but you know.
Epithemia?
It is epithemia. Epithemia. Oops. So the diatom that we're looking at right now is epithemia. You know anything about epithemia?
Not a lot. It's a lot in the samples, but it's new to me, so.
Okay. Epithemia are characteristic features are they have an eccentric raphe, right? It's on one side of the valve, but it actually then comes back towards the middle a little bit.
Yes. It comes up a lot.
You can see the ray view in this image when she slows down the beam. It's on the bottom side or the left side of the picture, and it comes up into the middle of the valve from the bottom side. Right there. Yep, there's a thickening, and you can actually see the ray view right there below where your cursor is. Right? That's the actual slit-shaped structure called the ray view, and they meet in the middle where the ray view ends. The proximal ends of the ray view occur. And what's cool about epithemia are that they have an endosymbiotic relationship with cyanobacteria that can fixate nitrogen.
That's wow.
Almost all of them. So
Like a coral.
Kind of like a coral, yeah. Except for here they've picked something nasty. Coral have a relationship with zooxanthellae, which
Yes,
are
they have a nice relationship.
a type of dinoflagellate, but the diatoms have a relationship with nitrogen-fixing bacteria. Cyanobacteria. They're the only type that can fixate nitrogen.
Yes.
And that's because the diatoms can't fixate nitrogen. None of the algae can fixate nitrogen, but they need it as a nutrient. And there's nitrogen all around us in the atmosphere, but it's inaccessible and for organisms to use as a nutrient, as a gas. So one thing that's nice is all the gases in the atmosphere are also dissolved into the water, and the cyanobacteria can then turn that gas into something that organisms can use. So the diatom gives them a home, and maybe some other things like sugars, and then the cyanobacteria provides the diatom with nitrogen. So
would that mean this lake is like not very rich in nitrogen or something like that?
if there were a lot of these, yes, that would mean that it probably doesn't have a lot of nitrogen, at least when this thing is growing, right? Seasonally, it can become, have a reduced nitrogen load. And I would actually argue that that's probably the case with all lakes that stratify. So you probably only find these in lakes that stratify, where nitrogen becomes limiting, and then these things will have an advantage over other diatoms. They also have a raphe, which means that it's probably benthic, and most of the epithemia and rhopalodia are associated with macrophytes that live, plants and large algae that live around the margins of the lake systems. So shallow water, sunlit, and usually epiphytic, growing on some sort of a macrophyte.
So we can tell a lot about these ones.
Yeah. You see how much you can learn just from looking at one diatom.
Yeah.
I can tell you all about, if you know something about the ecology of the organism, then you can reconstruct that even without having the lake present, right?
That's the magic of diatoms.
Yeah, that's the wizardry of
Paleoecology.
where you can basically, you don't even have to have a lake that exists today, and you can reconstruct what that lake is like, and all kinds of details. We know that there were probably plants. We know that there was definitely some areas that are shallow water. We know that it probably stratifies and has low nutrients, at least seasonally, right?
We had said it was probably Epithemia sorex. Is this the same one?
I think it's Sorex, yeah. Yeah, good choice to see that.
Maybe.
Shrink 46 says they'd eat that diatom. It does look a little bit like a croissant.
Yes.
If they were all pastries, if all diatoms were pastries, which one would you eat?
I don't know. Probably a centric one because they look like a pie or something. So maybe.
You're going straight for the pie.
Yes, I think
like
maybe
your choices. Pie is also
Lindavia, which looks like it's nice and fat.
Yeah, or it looks like a macaroon.
Yes, also.
Which was, you know, it's not a pie, but.
But it's
delicious.
tasty. Yes.
Yeah.
Oops.
I would like you to know, typically when I do like parties for the lab group, I will make key lime pie,
Ooh.
and then I will decorate it to look like a diatom.
We should have
and
a contest for decorating.
I call them piatoms.
That's very nice.
So we should have a party sometime this summer. coming
Next time we
soon.
just have a contest of the best decorated diatom pie.
Well, one Christmas what we did is we just made sugar cookies that were round,
Uh-huh.
and then we gave everybody icing, and then they were allowed to make their own diatoms, and then we could have a contest because then
There
it would
you
be
go.
fair
Yeah.
because we all have the same materials to work with as starting point. And then even if your cookie is hideous and terrible, it probably still tastes good.
You
So,
can still eat it and no one needs to know it
that's
was
right.
ugly.
You can eat your despair
Yes.
or your bad art. It will be fine. What diatom are we looking at right now?
I know, but I don't.
You don't know.
I do know we've seen it and we've named it, but I can't remember right now.
We were having a discussion about it before the chat started. And also chat knows what it is because I sent them a message.
We were discussing maybe amphoras.
But it's an amphora.
Yeah, I know we've seen it before. Because we have both. Like, it's complete.
Yes, that's the whole frustule for the amphora. And in fact, we're looking at it. Amphora also, when we were talking about how you separate amphora from other banana-shaped diatoms, is that for amphora, the raphes, when you have the whole frustule, are basically visible at the same time. So
Mhm.
both valves, you can see the valve face, which is what we're looking at right
Mhm.
here, at the same time in the SEM. Its dorsal side, which is the side that's sort of laying on right now,
Mhm.
is all girdle bands back there behind it.
Like here?
Yeah, around that side and around to the back side of the other one, it's all girdle bands.
Mhm. And this one's the raphe, yes?
And that's the raphe, and then on the other valve, your raphe is also visible.
And this middle part.
There's just one girdle band or pieces of girdle
Uh-huh.
band that come around this side, but on the back side, there's a whole bunch of girdle bands, so it's expansive, so that the raphes are both visible
Mhm.
from one view, and you'd never be able to do that with a cymbella.
Okay.
Because it's like box shaped. It either has one raphe visible or the other. Right?
Okay.
You'd never be able. Even if it was on its edge, you'd only be able to see one of them at a given time because
Mhm. It's one on
valves
top
are
of the other,
basically right
rather than-
angles,
uh-huh.
right? So the raphes are traced on top of each other. Yeah. Well, all we're going to talk about is food until you eat lunch, Pacific Plankton. But she said banana diatoms, and she's getting hungry. Also, I didn't eat lunch today, but Laura did. So at some point, I might just abandon her in here so I can go get food.
If you get hungry, please go.
I'm actually fine. I had breakfast, which I never eat. So I had a meeting this morning with Hung at 9:30, and I just ate cereal while he talked. So. This diatom is amphora, and the species is probably
This one I don't know.
Inariensis is going to be my guess.
Like this?
Yeah, close enough.
I don't want to get it misspelled.
There's no points off for spelling until you get to the publication stage. So,
I think this one might be the same one.
it is. That is also amphora. It's either pediculus or inariensis. I don't remember which one. Oh, look, Del Maximum is here. Hi, Del. Oh, you've got you found my BTTV new emote, the orange actinopticus.
Is this something?
Yeah, that's a dissolved fragment of Stephanodiscus caruscus. Do you see how I gave it two species even though it's just a piece of a diatom? If you get disgusted by that, just let me know.
No, I just thought it was like, I don't know.
Can
Not
you
a
see why I
centric
think
thing.
Can you see why I think it's Stephanodiscus now?
Yes.
As soon as I said it, it was like, aha.
Yeah, I just didn't think it was something centric. Rather something colonial.
I really should put Stephanodiscus caruscus on the Diatoms of North America website. It's a North
Yes.
American diatom. And I have all of the original information and pictures. And I don't think that Mark put it on there. Good night from the EU. Good night, McAllen. Have a good evening. Yeah, Pacific Plankton flashed up a Lindavia, and it's actually the Lindavia emote that matches the Lindavia that was on the screen.
This one?
That's a Stephanodiscus.
This one?
No, I think that's Intermedia. But she flashed up the little emote, the blue one. That's actually Lindavia. It doesn't have a name yet. We're working on naming it. It's like Ocelata. So that's the stuff up there. That's
This
a girdle
one.
band in the middle.
Mm-hmm.
It's a girdle band by itself, just the cingulum.
There's a lot of these ones.
Yep. And I can actually tell you probably where this sample is if I had that map. Because the map that you're working on, if this is a modern sample, which this is 7, this is F19, there's like one side of the lake that has a whole bunch of amphora.
Mm-hmm.
So you could have probably cheat and look at your heat maps you've been working on and use that to figure out what it is, where it is. That's also a Lindavia.
But this one is the inside?
That's
Or
an inside
yes.
view, and that's not one that we've seen before, or one that I have an emote of. So you probably don't know the name of that one.
Okay. But
See
I'm
how
taking
small it
a
is?
picture. Oh, yes.
And it's flat. Oh, this one is the Ocelata like one, and I can tell because do you see those little dark areas?
These ones or no, these
Underneath,
ones.
yeah,
Yeah.
those are the elevations on the
On
outside
the-
of the valve, and you can see that there's 6 of them.
1,
You
2,
counting
3,
5 or
4,
6?
5. Maybe this
Yep,
one is
yep,
the 6th one.
Yep, there's 6 of them. So that's exactly like the little emote that I have, but it's the inside view of that diatom. So this is Lindavia ocelata.
I'm taking
Or
a picture.
it is CF ocelata. It's not actually ocelata. I sent it off to somebody who studies ocelata, and they said, I don't know what to do with this thing. And then they sent it off to somebody else who studies them, and they also said, I don't know, this one's a head scratcher. So
maybe it's something new?
it's almost certainly a new species. So the dark spots probably aren't obvious to the audience because
Do they see my cursor?
they can see your
Okay.
cursor, yeah. So they probably saw you pointing them out, but it'll be a little bit clearer from this view than it was before because it was grainy.
Yes.
So the dark areas around here, these are the alveolar chambers around the outside. You're just seeing them through the little lip. I never actually figured out what the name of this lip is. I need to talk to Mark or somebody to ask them what this thing is called. I don't know the terminology for it.
Is it just like a projection of silica that covers?
It comes out from the mantle and then, yeah, it comes into the valve. I think of them as like bottle caps, and it's like the part of the bottle cap, like an old-fashioned bottle cap that kind of wraps around the top of the bottle. So, Dell says, what is the little bit of stuff at 12 o'clock on the interior of the outer ring?
This one.
Yeah, that's a bit of the girdle band or debris. And then these things that you can see that look like little tiny, I guess a face, if you'd like. That is the central photoportula, but it's slightly dissolved. And all you're seeing is the central hole and the 2 satellite pores that are next to them. So this diatom has central photoportula with 2 satellite holes. And if it's a traditional Lindavia, which it isn't, but it probably has marginal photoportula that are
Somewhere.
visible right here and here and here. You can see them
Yes.
right there, every other or every third, that are probably 2 or 3 satellite pores on them as well. And that is the rimoportula over there. And this is the bone of contention for this group because it's not on the valve face. And it's supposed to be.
But it's not.
It's not. It's clearly sitting right on the edge. And there's another one down here that is also right on the edge. And so its position is dubious at best about where it should be versus where it is for this genus and the species in particular. So, yeah, it's just a bit of the girdle band that's stuck to it, or maybe a little bit of clay debris. But I think that one was actually a bit of the girdle band. Need to hit the red X to get rid of the picture.
There. These ones are the.
Yeah, you can see those circles on there now, right? I can see them on the screen here, so, but it's because we're looking through the diatom, not at the structure, so they look very faint, right? We'll find an outside view, and then we'll have Laura zoom in on it so you can actually see the elevations, and it'll be basically the picture that we use as an emote, or the one at the top of the the one that's actually my icon for the Diatoms Attack Live. That's actually that diatom. The little live logo's under it, except for it's red there, and the one that I have on the screen for the emote is dark blue. But it's that diatom, basically. Del wants to know, is this an ancient diatom or modern? And the answer is, the sample that we're looking at is a surface sample.
So it's modern.
It's modern-ish. They weren't collected from the water column. The diatoms were dead. But
it's relatively recent.
it's within the last 50 years or less, because I think they used a ponar to collect it, so it just grabs a bunch of sediment. This is a Lindavia as well, but it's a different species, and we're looking at the outside of it, not the inside of it. And this is Lindavia costii, and I know that because I've studied this sample, obviously, quite a bit, involved with publications on it and whatnot. But also, the features of it are different than the one that we were just looking at. It doesn't have the elevations that we saw.
That's what I was looking for, and I was like, no.
But this is a good diatom to take a picture of because it's also smaller. The scale bar on this one is at 2 microns.
The other one was 5, right?
And the one that we were looking at was 5. Yeah, so it's about half as big as the one that we were just looking at. And then there's some really cool features that are visible through the, just hold the picture up in front, that's fine. Through the valve. Like before we were looking at features on the outside of the valve from the inside, but now we can actually see some of the features that were on the inside of the valve on the outside.
On the outside?
So this is a different diatom, but these are the marginal photoportula right here, the ones that I said had 2 or 3, and they occurred in every 2 or 3 costi. So these structures are the costi. These are the alveolar chambers here that have sort of a mesh over them, where the striae are slightly wider. And then those are the marginal photoportula, the external expression of them. So you can see that those things that were on the inside that I pointed out when I went around the clock, they have an outside hole. And then this guy right here is the rimoportula that we saw on the other one. It was actually, we had like a position closer to the margin. But the rimoportula on this diatom is clearly on the valve face. So this is a well-behaved Lindavia, unlike that other thing. Which is, I think, belongs in Lindavia.
So this one on the other side looks like a little...
Mouth. Yeah, lips or a mouth. Yeah. The space between the alveoli are costi, yes. And that costi just means a rib.
Like this
It's
part
a
without
thickened piece of
string.
silica, and the alveolar chambers on the inside are just openings, and in this case they have that sort of meshy areoli structure over top of them on the outside. So, and then the center hole, that single hole there, is probably a central photoportula. I'm not positive about that, but I think that's what that hole is on this diatom. So if we were to flip it over and look at the inside, we'd see one central photoportula, one rim of portula,
And
and
those
then a
are-
ring of mantophotoportula that occurred every 3 or 4 costae. And like a well-behaved Lindavia, it doesn't have any spines. All Lindavia, as far as I'm aware, don't have any spines. And in fact, Ocellata, or that CF Ocellata thing that we were looking at, also doesn't have spines.
So it is Lindavia.
That's
probably.
where I would put it, because Cyclotella have spines. They're not
And
always present.
Stephanodiscus as well.
Stephanodiscus always have spines, and Cyclotella almost always have spines, or they're usually present with spines. But Lindavia usually do not, and I don't think any of the Lindavia have spines. Not that I remember off the top of my head. Anyway,
So-
Costei, C-O-S-T-E-I.
No.
C-O-S-T,
T-E,
C-O-S,
like that? Because...
C-O-S-T-I-E-I. Yeah, you had it, right. Costei. Costei. It used to be Cyclotella unipunctata or something. Because it
Got
has that little
moved.
tiny hole, and you can see that in the light microscope. People used to call it unipunctata, but somebody came along and named it for that Costei, and they figured that out relatively recently, in the last 20 years or something. So,
Ooh.
that's a nice picture.
This one's Fragillaria crotonensis,
Yep,
maybe?
yep, exactly. Good. 2 species. You're doing well. At least
no,
as
I
good as
moved
me.
it.
Fragillaria. Oh, I did my command wrong. Yeah, so normally what we do is zoom in,
More?
yeah, to get it in focus, because you probably want the striae in focus cleanly, and they're maybe a little blurry.
Yeah.
The ones up there are most obvious. Yeah.
Yes, these ones.
And this species for this one is, it's Fragillaria crotonensis. And for anybody who's wondering where do we get these weird names from, ensis as an ending in Latin means named after a place. So in this diatom,
What place is it?
Croton.
Where is that?
I don't know. I could Google it probably. But when it has ensis at the end of the name, it usually means it was named after the place where it was found, originally described from. So, like, if we described a new Lindavia, we could call it Junensis, right? Or June Lakensis, or Californiensis. But the ensis ending usually tells you that it's being named after a place. So, I will only do that if I'm being lazy, or if I think a species is endemic. So I could have called the Stephanodiscus that we found here Junensis. I just didn't like that name. I didn't think it sounded very interesting. And so when I described the Stephanodiscus from this lake, I picked Coruscus, which means gleaming, because in the light microscope, they look like radiant suns, little radiant suns.
A little bit more
gleaming.
poetic
And
than...
it seemed much more poetic to me. There's a croton in Italy, says Kalakon's doing some Google work for us, so probably
Maybe
named
that's
after
it.
that. There you go. So, almost certainly named after a place called Croton or Croton, something like that. Um, but you can learn a little bit about your lake system from this thing as well.
Yes.
So Fragillaria crotonensis is a plankton. It doesn't have a raphe, and it's not colonial in the sense that those little guys that we saw are, but they actually can form like ribbon kind of colonies,
Mm-hmm.
but they're still plankton typically. And usually it's found in systems that have elevated nutrients. So the funny thing is we found something with low nutrients
Uh-huh.
together with something with high nutrients. And what that should tell you is that seasonally the lake system switches between high and low
Uh-huh.
nutrients,
Yes.
right? And usually it's associated with elevated nitrogen. So the thing that's missing
There's a
from the other
nitrogen.
one,
Yes.
the thing that's
There's a
present in
nitrogen
this.
thing going on.
So there's some sort of nitrogen relationship going on in there where seasonally this thing would be present and the other parts of the season, the epithemia would be
Mhm.
present. Also, they're usually associated with like eutrophication of systems from anthropogenic additions of nitrogen. Although that doesn't necessarily need to be the case here. They can have natural sources of nitrogen in lakes, but the fact that it's missing from the lake parts of the year and then present in parts of the year,
It's
again,
like a
suggests
switch.
it suggests that the lake system has a seasonal stratification cycle, and at least in the water column, it's present for parts of the year. So I would, the coupling of those two things together. One thing I would say is you don't want to base all of your interpretation on just like one
One.
instance or one species.
But you start getting clues
Right,
about what's going
right.
on.
If you find a bunch of epithemia and a bunch of crotonensis in the same sample, those are probably an indication that that's a lake that stratifies. And seasonally, the nutrients are missing from it, and then will appear occasionally.
And allow these ones to.
Probably in the spring and the fall, right? When a lake turns over through isothermal mixing. So, and the end on this one is broken off.
Yes.
But the other end of it looked
It's
like
very pretty, the other.
Yeah, the other end looked like a nice clean view of the inside of that crotonensis. So,
I'm gonna go and spy
yeah, go
on
look
this
at it,
one.
because I think there's actually a Rimiportula up there. I think that bright spot I see right at the tip is a Rimiportula. It could also be a piece of junk. We're really far out. Yeah, maybe it's just junk. I thought maybe it was going to be a really pretty labiate process, but it looks like it's just
No.
junk.
But do we see some spines?
Yeah, you can see the spines that are present, and these things, like I said, will form sort of ribbon colonies or zipper colonies, but still in the water, still floating in the water. Mean Machine Rex says hi.
Hi.
Does it feel like we've been going on for an hour yet?
No.
It's been an hour since we started. I swear, we're on the SEM, it's always just like,
Time flies.
that
I
was
don't
an
know.
hour? Why is it when I'm at the dentist it doesn't feel like
Ah.
this sort of speed?
This one's like a fragment, right? It's not.
It's a broken fragment.
Mm. Here's another one.
Crotonensis. That's the stuff.
This one, right?
Yeah, it's an internal view of the stuff in a discus. It's the other thing, you get really good at seeing stuff from the distance in the SEM to help you characterize it.
Mhm.
Even looking at them from really far away, I can tell what it
Oops.
is. That's Corescus. Stephan discus Corescus. It looks like it has a little bit of
Something
junk
here.
on the surface there. but you can see the labiate process really well.
This one.
Yep. Yeah, I don't know how good it's going to be because it probably has a lot of junk on it. But those are the cribra, and all of the Stephanodiscaceae group have domed cribra, which means all of the things that belong in that category. I think it's actually even higher. I think it's Glessus auralis. All of those have domed cribra as well. So if they have cribra, if they have areolae, they're domed cribra, which means that the inside of the diatom has a little sort of like salt and pepper cover shaker covering over the holes, which look like little round half spheres.
These ones are the mantle full toportula.
Yes, those are mantle photoportula. And in Stephanodiscus, the place where you have your cursor would be a costi, or what we call interfascicle, and then the combination of sort of pie wedge of areolae that are between it, we would usually refer to as fascicles. And fascicle is just from the Italian word fasces, which is like a bundle. So it's like a bundle of areolae bundled together into little packages by the costi. And then if you look at the structure of this one, there's a mantiphotoportula at the end of each costi, right? So when we were looking at the Lindavia, it was like every 2 or 3.
In all Stephanodiscus?
Nope, not in all Stephanodiscus,
Okay.
just in this species. There's a costi at the end of, mantiphotoportula
So
at the end
this
of
part
each
is further or it's further?
further in, yeah. So there's a 3-dimensionality to this where it's flexed inward. And
So it's like a little cone when you look at
the
the
or
other
bowl.
side. Okay.
It's where you put the ice cream.
Yeah. Now that we're talking about food. Yeah,
Welcome back,
I made a little diatom glossary with all of these names.
Oh, you did?
Yes.
You know there's one on the Diatoms of North America webpage?
Yes, but if I don't write it down, it
Oh, okay.
doesn't.
Doesn't stick in your brain?
So yeah, I carry it around, and
You need to
hopefully
get
I
one
will
of
learn
these,
it.
you need to get one of these upgrades where it tells you what species things are.
Eventually.
Where you just look at stuff and go, yeah, it's that species. I don't know why or how. I don't have a book. I haven't looked at the book for 20 years. But here, it's this species. And then when somebody goes and looks, that you're right. That's the most important part. Yeah. That's Caruscus. So Caruscus, importantly, doesn't have any...
Mickey Mouse.
no Mickey Mouse ears, no central photoportula in the valve center, and that is characteristic for the species,
Okay.
not for Stephanodiscus, but
Just
that
Caruscus.
species. Yeah. So some Stephanodiscus have them, some don't. But the number and position of the central photoportula are really good indicators for Stephanodiscus species.
It's double R?
Coruscus, yeah, you got it. Nidhogg says, aren't masks needed there? Both Laura and I are completely vaccinated now. So I got my vaccines completed at the beginning of April, and Laura, as of today, is fully vaccinated.
Yay.
So she got her shot last Thursday, second shot. So we are both completely vaccinated, and as a result, we're allowed to be together in a small space where there's no other people, without any concerns. That's a good question, though, Nidhogg.
In COVID times, yes.
Normally on our streams, we all have masks on, but or I'm in here by myself. But starting this week, Both Mallory and Laura are completely vaccinated, and we don't need masks. So. Oh, even where everyone's vaccinated, you have to wear them. Well, that's fortunately not our case here, so we're able to get away with it. Or at least I feel like we are. No one's told me I couldn't, so. You had it for a second. There you go. Nice and sharp. You just sped it up. It's fine. Speed's not a big deal. At least the CDC guidelines are
Yes.
small groups of people can be together. So
If they're vaccinated.
Yeah, if they're vaccinated. Do you know which one this is?
I'm thinking about it. I think it's one of the Starro babies, but I don't know which one. Pinata
It is,
maybe, but I don't know.
It is not Pinata. It is one of the Starros, and
Yes.
you had Starros. Something is correct.
Yes.
It's got STAUR in the name.
Because construents is different, right? It's more.
Mm-hmm. It's
Or
not
it's this one.
construents.
Okay.
You should be able to tell by, think about how far the striae would, if you were looking at it in a light microscope, how far would the striae come into the valve?
Not very far for this one.
Correct. So if it just has the striae that come a little ways into the valve face, and they don't have linealations on the surface, so the opening is occluded completely with this sort of weird structure covering over it. It doesn't have the little lines, which is what you would see in Starocyrella. And
So I'm thinking it's Pseudostarocyrella?
it's Pseudostarocyrella. This is Pseudostarocyrella brevistriata. Regular Cobalt Ethon says hi, and they want to know what is this for a sample. What sample is this?
This one's a surface sample for June Lake.
It's a surface sample from June Lake, California.
Yes.
Yep. And this is Pseudostarocyrella.
It's a big name for a small diatom.
Yeah, it's a very big name for a very small diatom. And this one is actually Pseudostarocyrella
brevistriata?
Brevistriata. Yeah, brevistriata. Which just means little striae, short striae.
That's a good clue for the future.
Yeah, a nice, easy clue. And they usually have this shape, which is spindle-shaped or football-shaped structures. When they get a little bigger, they actually start to flatten out on the sides. So if you look in the middle, this actually is starting to come a little parallel right in the middle. When they get a little bit bigger, or rather,
They lose that.
when they are a little bit bigger,
that shape.
They tend to be a little less football-shaped. This one's a small one.
Pseudostarocyrella.
It sounds really awesome because it is really awesome.
Brevistriata.
So when we're looking at everything in a scanning electron microscope, if you're not familiar with scanning electron microscope, most people probably have never seen one in operation if they haven't been hanging out in my channel, or you don't have access to one in a lab where you work.
Oh, this one.
But you've probably seen pictures of things that have been imaged by a scanning electron microscope before. It doesn't use light. It just uses electrons to see. So
This
here-
one's the one I meant.
that's construents. Yeah. That is Starocyrella construents. I didn't want to ruin it for you, but yeah.
Is this part of the same?
It's the same thing.
Okay, so I want everything.
Yeah, you can see the shape, and then you can also, if you just moved over a little bit farther, there's
like
an outside. Yep, that's
on
the
this
outside. It's got a little bit of junk on it, but that's the surface on the valve
on this
face on the
side,
outside,
yes.
and that's the inside.
We are
So you
taking a
might want
picture
an
of
inside
everything.
and outside, and then there's a, it's
The-
a whole colony, so you've
The
got,
girdle view a little bit as also.
you've got 2 valves, 2 frustules there with 4 valves. Oh, Nighthawk says, I can't tell diatom species, but you use them to make arrangements on microscope slides for fun. So Nighthawk, do you have a micro manipulator, or did you use like an eyelash and a paintbrush to manipulate them? So we do have a micro manipulator in my lab, but it's not outfitted with a probe, eyelash probe to arrange slides to be pretty. Regular Cobalt wants to know, are you counting them or are we categorizing them? Yeah.
So for now, just categorizing.
Yeah, so these samples have already been counted. The ones that we're looking at were all counted by me. I analyzed them, so I'm hiding off camera. Yeah, there you go. But the lake that's adjacent to this one is Gull Lake, which Laura is going to count for her master's work. And she's going out to Gull Lake to collect the cores in a month.
Yay!
Almost exactly.
Yes.
So she'll be flying to California and working with some other scientists from the University of Kentucky and Mike McGlue's lab to collect some of the cores, and then flying back and sampling them and processing them and turning them into slides and then analyzing the slides. And we'll also be digesting some of those samples and looking at them in the SEM as well. So, but because the 2 lakes are really close to each other in space, there's basically, we think a time in the past where the 2 lakes might have been joined together when lake levels were much higher. And so very likely a lot of the flora that are present in one are present in the other as well. So she's sort of learning.
Some training.
We're training. We're in a training mode right now where she's learning both how to use the SEM, and which she mostly knows how to use you can see, and also I'm sort of teaching her the species, so and how to easily identify them in the scanning electron microscope, which is half of the work, is being able to easily identify things. Scanning electron microscope is not what we typically use to count diatoms, though, because it's...
It would take a long time, I think.
Probably you could do it relatively quickly, and probably more accurately than a light microscope, but most labs don't have time on the SEM where you can just sit there and count.
Mm-hmm.
And so the way that you'd have to do it is probably put the image quality at a lower resolution and just take pictures every time you came to a diatom and then count it later from the pictures.
That doesn't, yeah, no.
I mean, that would probably be the simplest way. I think that's how Josue is doing his work for looking at coccoliths. But, you know, so there's a value to doing that, but typically we wouldn't count them on the scanning electron microscope. We just identify them and then look at the actual light microscope samples and compare them with what we found in the sample here on the SEM, and you know, make the connection between them mentally, and then just count them on the light microscope. So, yeah. Nighthawk says they use glass needles in a micromanipulator. Good. Regular Cobalt Ethan said, I have access to an SEM for like 3 months or so. It wasn't a good one, but it was fun. I think it's actually a lot of fun to use an SEM. We sometimes on my stream just sort of look at stuff for fun as well. Put things like, a couple of weeks ago I collected flowers, and then I shook the flowers pollen onto stubs, and then we looked at the flowers and the pollen together, So as an example,
This one's a different navicula, right?
it's navicula. Yeah, I don't know which.
But it's not
species.
oblonga.
It's not oblong. It's way too small, and also the shape is wrong. So the ends are acute,
Mm-hmm.
or actually just narrowly rounded. But it does have the traditional striae for navicula, which is the way that you can tell it's navicula sensu stricto. This sort of boat shape, which is where the word navicula comes from, like navy.
Oh, really?
Navy, navicula, right?
I
It
don't
means
know.
like little boat.
I hadn't thought of it.
You had? All the names I always try to think about what they mean because it looks like a little boat. So navy, navicula, like the connection's always in my mind. Do you know what stephanodiscus means?
You had told me because I thought it was someone.
Right.
And you told me it was like a crown or
Yeah,
something.
yeah. So stephano is a crown, and discus means a disc.
Disc.
Yeah, so crown disc. And it's because they always have the little spine sticking up on the outside like the crown, like a king's crown does. This one that we're looking at is a navicula. Let's see. Lucy is here. They say hello. They finished planting. They're a farmer, and they may be able to see more of our streams as a result, unless they're playing with their kids. Good choice. Nighthawk says they're a microscopist without a lab, so they got tired of waiting to be hired and to play with those instruments and bought one for their home. Ah, good. I have a microscope that I borrowed from my own lab that's at home, and then I have my own microscope as well that I bought that's at home, but I don't stream from the one that I bought. I stream from the one from the lab because it's
Nicer?
about $18,000 nicer.
Oh.
So, I use the nice equipment to stream from. But yeah, Dell also does microscopy on Twitch from home, and Pacific Plankton, who I think is maybe eating lunch because I haven't seen her say anything for a little bit, does microscope stuff from home on Twitch, and there's a whole host of people who do microscope streaming on Twitch that you should check out if you're interested in that. And I also will sometimes stream from the light microscope at home, but during the daytime when I'm here,
Oh my god.
that's somebody following us.
Okay.
That was a new follower, Cobalt. That's what happens when people follow. It sends out a little sound alert, and I normally turn it off on here
Good to know.
so that I don't get startled by the computer starting to speak at me. But you got Laura good. So,
Yes.
it's only really bad when I'm at home and I'm looking in the light microscope and it
And you-
happens and I like jerk up and give myself two black eyes almost from it. So thank you for the follow. You can find an old one for a few $1,000s. Yeah, that's what I actually bought my old microscope at home for, like $2,000. But I actually bought a very special microscope. The microscope that I have at home, that's my personal one, used to belong to Eugene Stormer, who's a very famous diatom taxonomist in the U.S. who trained practically every diatomist, in the last 40 years or whatever. Mark Edlin, Sarah Spalding, Ed Terrio, just Pat Kaselik, they all came through Gene Stormer's lab, and he also trained myself and my wife in diatoms, and he passed away in like 2012, but he was the person who sort of really got
Is
me
this
well
something?
trained. Yeah, that's a diatom. I can't see any of the details. It may
I
be
think it's covered
inside,
or
covered with
I
clay
don't know.
inside. I think maybe it's a cockanice, but it's an internal view, and it's covered.
Yeah, I'm not seeing much there.
So I bought mine for sort of like, sentimental purposes as well. It's a nice microscope. It's got good optics, but it's not like a modern microscope. It's an antique. But it's the one that he used. It's from his lab. And So it has special meaning for us as well, and we can still use it for analyzing diatoms. Um, but I have a nice new microscope that I just bought, and I have that at home instead because Carlin and I are analyzing diatoms, and we need to be able to stream from it and take pictures, and that's a nicer. It's a nicer microscope. It's got DAC. So, yeah, I don't think you could buy an SEM for fun.
Oh, no.
Unless you're kind of rich.
A lot, like really rich.
Rich enough that you could buy another house for fun, because they cost about as much as a house. So, roughly equivalent to a house. And you can't live in them, typically. Yeah.
So here are two different sizes. The Coruscus is the smaller one.
Yes, I think so. I need you to zoom in on them a little bit so I can see what's going on, because it's... Yes, that is a Stephanodiscus Niagara.
But this one is the inside view,
It's
right?
an inside view. Do you see these things right here?
Uh-huh.
Those are central photoportula. So I know it's not Coruscus, right? From
Because
the
it doesn't
beginning,
have any.
It doesn't have those. And the position of them and the size of it tells me that it's Stephanodiscus Niagara. I'm gonna say Niagara with little quotations around it because there's a lot of things people call Niagara, and I don't know which one is the right one.
Okay.
But this is in that family or people
Group.
subspecies or species of Niagara. But it belongs to Stephanodiscus. It's a well-behaved Stephanodiscus. It has fascicles and interfascicles, and also on the outside spines, subtended by mantle photoportula. So, and we got a new follow from Ernst. Oh yeah, Nighthawk says I saw some of my home light microscope streams as well. Yeah. Mean Machine Rex says Jellickson and I were adding chemicals to his slides. You were giving him some dodgy ideas. And Dell wants us to know that Melinda Gates is now single. Unfortunately, Dell, I'm already married, and I don't know if she got half of his wealth, but if she did, I suppose that would make her pretty available. But I'm happy with what I've got. So she could buy you a lot of SEMs, though, if you married her.
Good to know, but unlikely.
Yeah. I think she may be a little bit too old for me anyway, but you know. Let's see. Mean Machine says, how do you get inside? I think that's, by the way, slice it open. The inside view, view. The inside view is because the diatom valves will disarticulate when they die, and especially after we process them. The girdle bands, which are the part that kind of holds the two cell valves
Together.
Cell halves together, will break apart or disarticulate when you put some really strong acid or oxidizers on them, and then also if they just decay. So these were, not living material, but fossil samples. And so when the girdle bands break apart, the diatom usually breaks open or falls apart. And so sometimes they land face up and sometimes they'll land face down. So inside views
50-50.
It's not actually 50-50.
Which side is heavier? Or
In the SEM, it's more likely that they're going to land this way.
the other, like,
Because
inside?
the aerodynamics are such that you'll likely see the inside more typically than the outside. If you think about, like, a bowl falling out of the sky, it's more likely to flip over, and then it would fall more aerodynamically like that. It's the same thing for diatoms. They're more likely to flip over, this way. If they land on their edge, they could fall 50-50, right? Which they might also go through the water column like that, right? But if they were actually falling through the water column I would expect that they would flip over
That
probably
way.
and land that way. Regular Cobalt Ethan wants to know, would I be interested in samples from the other side of the world? Yes, I would.
Naya.
Niagar. Gar.
Niagar. No, Gar.
Ae.
A.
Niagara.
Niagara.
It's from Niagara, like Niagara Falls. And Nighthawk says they're interested in diatomite. Yeah, I don't know where you mean by the other side of the world, but if you have samples and you want us to take a look at them, and you know they've got diatoms in them, and you think you can get them through customs, by shipping them to me, send them over. I'll take a look at them. Probably easier if they're not modern samples. If they're sediment samples, you can usually get them through customs if you call them rock samples. Just don't tell them that they're full of biological components, or they're going to get caught at customs and basically thrown in the trash.
That's pretty.
That is an external view of
The Croscus
Nope.
one? No?
Definitely
Oh,
not.
no, Lindavia.
That's a Lindavia.
Yes.
Do you know which Lindavia?
We have Lindavia ocellata, and we have another one.
Costii, and this is neither of those.
Yeah, I don't know. It's the strange one?
This is intermedia,
Oh.
so it's larger than those other two by a lot. Move the picture over, we probably could see. I meant onto the field of view. If you use the mouse wheel and scroll outward, if you keep going, it'll actually put the
5.
Yeah, so the field of view on that one is almost 30 microns across. The field of view, like the maximum field of view for Costii is like 10 or 15. It's about half the size of that. The ocellata one is a little bit bigger, but it's smaller than this. And it also has those elevations. This doesn't have any of those. So you can zoom back in actually so they can see all the detail. But you can see two different types of holes on the valve face. These are Mantophotoportula, and these are areoli. And then this one, and out here is another one. These are the Rhemoportula on the valve face. So well-behaved Lindavia.
Okay.
And also, you see these things out here.
Yes.
Those little holes that are a little bit bigger, and they have like kind of like a silicate, and they're right at the end of a costi. It's Mantophotoportula. Also no spines, right? So
Yes.
Lindavia. And this is a special group of the Lindavia. These are the Bedanicoids, which are like Lindavia bedanica. And the striae split, and then they split again out here at the elevation of the alveolar chambers. So you can see here's a split. You see how it bifurcates right there?
Yeah.
And there's another split out here. So there's these things that split all over the place, but they particularly split as they get right at the alveolar chamber and then sort of fork over.
I wish
the
it didn't have
chamber
this.
window. You got a little bit of junk on there, yeah.
Because it's really pretty, but then it has a little bit of dirt.
It's always the case. You have to keep looking until you find one that doesn't have any clay on it. And then take a picture of that.
Yeah. For now, we have this one.
Yeah. We'll settle.
Yes.
I'm thinking I get samples from Bies Bosch or Issel Lake from the Netherlands. Okay. You're not sure about customs. And I don't know what's in the water over there. There's a pretty good chance if you took a sediment sample from shallow water, like a little bit of mud off the bottom, that it probably has diatoms in most lake systems. They're very common. They're the base of the food web, basically, in aquatic systems. And so, unless there's no silica in the system, which is really uncommon, or it occurs usually where you have too much nutrients and all of the diatoms have stolen all of the silica from the water, then usually you have diatoms The only other case where it wouldn't occur is if the diatoms are actually dissolved, which happens when the pH gets very high. So.
This one's a Lindavia?
That's intermediate. That's the internal view.
Okay, let's get this one so I know what it looks like.
So the bright spots that aren't mud
These
or
ones.
dirt, yep, those are the labiate processes.
The three big holes that we saw on the other one?
Yes.
No.
Yeah, the two, I think there was
It was
two.
two, yes.
Maybe there's three, but there could be three or two. And
I think
if you
I'm
zoom in and look
making
at
it
that,
pretty,
zoom in really close on the
the
Manta
Mickey Mouse.
photoportrait, yep, you'll see that they're triangle shaped. Yeah.
There you go.
And it's a nice clean view of them, and they'll look really sharp when you. I think you could even get better than that. You're gonna get zoomed in like crazy, and then
This one.
you can. I think you can get those even cleaner. So you might want to put the little box up and then see what you can do.
Which one?
Double click. I mean,
Ah,
so
yes.
it's not redrawing the whole screen.
I can make it
Yeah, the other button and drag.
this one? No. This one? No, this one. Ah, which one?
the like this.
Okay.
So this right button, but you have to click inside the box and then drag,
Okay.
and then you can reposition it. You can always Photoshop it to perfect. Well, it has to be in focus to Photoshop it to perfect. That's a
No.
you can't fix.
Oh.
You can fix out of focus a little bit if you have like topaz or something. That's pretty good.
I think so.
Yeah, that's good. And you can actually see the
This,
little salt and pepper shaker heads, the
Yes.
internal quiver really well now. And especially when we zoom out, those will be super sharp now. So
Nice.
you can see these have like a ring of strutted processes, and then I think another ring on the inside of that on occasion. So like two rings of strutted processes around the middle. So this will like maybe an interesting one. It used to be a sea, but we dammed it, and a lot of fish died. And right now it's being fed by a couple of rivers. I mean, it counts as a lake if you dam it.
A little
just
bit like Panama, right?
reservoir. That's actually a pretty interesting lake. I know something about it, but I don't remember what I know about it. Off the top of my head, I remember reading papers from there. I think people have actually analyzed the diatoms from that lake before. And Bispash is pretty much a swamp, but that's also fine. There's diatoms living in swamps. That's a regular.
They live everywhere.
Yeah, anywhere there's water, basically. So, look how nice that.
It
focus
is pretty
now.
nice.
It's like you got it perfectly in focus, and that looks good. Look at the labiate process, how bright it is.
And you can see the pattern on the outside as well, so that's very nice.
Those are where the costi are. You're looking through the valve, the internal basal siliceous layer, and you can see the costi through them. That's because we have the accelerating voltage at 30. If we lowered the accelerating voltage down to 5, you wouldn't be able to see through
Okay.
the structure, probably. You wouldn't even see bright spots where the costi are. You'd just see like a flat sheet. And the appearance of the diatom would change a little bit as a result, because it wouldn't have that sort of depth to the structures. They would look very opaque, basically. So. But that's a nice view. And you can see out here as well the structure of the marginal photoportula. And here very clearly the valve face photoportula. And then these are the, on the inside of those are all
The shakers.
areolae that have the dome cribra. Do I have samples from outer space? No. It turns out, yeah, they don't have diatoms in outer space.
We don't know that.
Probably. Probably not from outer space. There have been some reports that people found diatoms on asteroids, and they assumed that they came from outer space, probably incorrectly, because the diatoms they found were Nitzia, and I feel like if you're going to have a space diatom, it's probably not going to be the same as an Earth diatom. That would be
Yes.
found in a similar place on Earth with Earth DNA. It would be, a space diatom.
Entirely different.
Something
one.
different. And I think if diatoms were growing in 0G, they would actually look really weird, especially if they were Earth diatoms that went to 0G to grow. So, yeah, internal, that's what I do.
I was going to say inside.
They are like spaceships, though, shape-wise. This one particularly.
Yes. I wanted this one. Lemon shaped.
Lemon-shaped, yeah. Well, an elongated lemon.
I don't know. It's covered in something.
Yeah, it's got clay.
But what is it?
Can you zoom in a little bit?
Can't really
It's
see.
Animastus pseudotusculus or Animastus rostratum. I think it's rostratum. It's an Animastus.
I don't know if it's covered.
It looks like it's covered with clay.
I don't.
Normally you'd see all kinds of structure in there. So
Yeah. I'll find another one.
find us a good one. Creak.
You don't have diatesmis in any of these?
You can find those. Diatesmus is a diatom that's most commonly found in it's an aerophyte, so it likes like
I had it a lot in
subaqueous
my-
environments. It comes from like bank erosion or
This is nothing.
I don't know what that is. It's not a diatom. It's something.
But I don't know.
I don't think it's a diatom though.
Yeah, I had it a lot in my samples because these lakes are very dependent on seasonality. So it dries a lot when it's dry.
Yeah. So anytime you have like exposed sediments
Mhm.
or mud or surface soils, you'll get things like diatesmus and lenticular and
Ooh.
what else is common? Ellerbeckia. I'm trying to think of the genera that are like the most common when you have.
This one's covered as well?
I don't think so. I think,
It says Sternis.
I think it's a star anise.
Sternis.
Did I say it wrong?
I think I said it wrong.
Oh, you said star anise.
No.
Cobalt Ethan says, all I remember is that I understood microchips much better after 30 minutes with an SEM. You mean much better than diatoms? Because I'll just let you know there are thousands of species of diatoms, and probably more reasonably hundreds of thousands of species of diatoms. And in North America, it's limited to about 9,000 that we know, but probably the true number is much higher than that. And there's a lot to learn about them as a result. So microchips are man-made. They're pretty easy to understand because we make them. Although That doesn't mean I understand much about microchips, but the general concepts are pretty familiar to me. You have silica and gold, and then some, circuits. But yeah, that's what you understood. That's what you meant. Do you know what this? Oh, we got this is a star anise, right? I don't know what this species is though. There's a lot of star anise. I don't know the species. I've never had this one in my own samples, but I think this one is actually on Diatoms of North America on the web page, and I should send that little star anise. There we go. So these are only their shells, and all their organs and organelles are gone. Yes.
Yes.
Diatoms make a silica-based cell wall, and what you're looking at is the skeleton of a diatom in every case here. These samples were processed in hydrogen peroxide.
So nothing living can possibly
most
come out of
carbon-based things, what happens is the hydrogen peroxide donates oxygen to the carbon, turning it into carbon monoxide, and then another oxygen gets donated towards it, and it becomes carbon monoxide. Carbon dioxide, and then those are both gases, so they just degas from the sample or bubble out of the sample, and that's an exothermic reaction, which means that it speeds up because it heats up the water when it occurs, when you turn something solid into a gas, and that actually speeds up the rest of the sample from being processed as well. And the combination of elevated temperature and free donation of oxygen from things, because hydrogen peroxide is H2O2, means that what you're left with is mostly water and then a bunch of carbon dioxide that degasses out of the sample. So, and then what's left over is things that don't have carbon in them, and in our case that's diatom skeletons. The chloroplasts and the cytoplasm and the rest of the organelles basically all have carbon in them, and they get decomposed pretty quickly. Scoop Dim Cookies. Thank you for joining, for following. Apparently they like to scoop cookies. Hopefully they mean like into their mouth. Yeah, so regular Cobalt Ethan says, honestly, these kinds of microstructures are just so beautiful.
Yes, they are.
And I think that's actually part of the appeal of studying diatoms for me, is that the organisms themselves are very charismatic, as we like to say. They have all of these really interesting, intricate structures. Wow, there's something coming out of the screen at us.
Yeah, I
over here.
know. But these are cerealas. This
Yes.
one's just covered.
It's like there's a
I
hair.
wanna see if this one's a different one. This one's the Carrasco's one.
Probably. Although it could also be, it's really small, so it could also actually be Stephanodiscus minuculus. And the way that you would tell is, I think it's probably minuculus. The spines are too small for Carrascus.
Okay.
And its size is also very small.
So
And-
Carrasco's is a little bit bigger?
Yeah. It's the very small versions of Carrascus are still this size, but their spines are
Bigger?
longer. And minuculus usually has little tiny spines. And my guess is if we analyzed it, it probably would come out as minuculus. But I'm not positive of that. It could be just a tiny Carrascus. They're very close when they get small. So, and I think we did find minuculus in these samples.
Okay.
So, if if we saw the inside and it had
The-
central stranded
uh-huh.
processes, we'd be like, that's my nucleus. You can see all the features that make it staphylococcus right here in this image, though.
This one.
The spines at the ends of
This
the
one.
interfascicles or costi, and they're subtended by a marginal photoportula. This is staphylococcus. And then little pie wedge shaped spaces between the costi, and that's pretty much all that you have to go on. We know that it's not anything closely related, because the things that are closely related would have costi that continue all the way to the girdle veins, and that would be cyclostephanos, for example.
So these ones go further.
These ones stop at the mantophotoportula or at the spines themselves. It's hard to tell, but for cyclostephanos,
It goes.
they go all the way to the outside
Okay,
edge.
that's good to know.
So only visible really in the scanning electron microscope. End up with all these tabs open where I'm like grabbing diatom species and genus information. So most of the day, somewhere between like 25 and 40 viewers. So, and typically, if you go back and look at the video on demand for most of my streams from the SEM, like 200 to 300 views total, usually something in that range.
That's a
on-
lot.
on
I thought,
Twitch.
I don't know, less people were interested in diatoms, I guess.
They're probably not that interested in diatoms. They're probably just interested in the pretty pictures we take. You know.
But that's something.
Monster Munch says this looks like a lamprey's mouth.
Oh, that's
does a
not
little
very
bit.
nice.
If you think about the way that the lamprey's mouth is arranged, they have a whole bunch of nasty little spines.
No, discuss.
around
What was it?
My nucleus, I think.
Minutulus?
Minuculus. Yeah, I think that's right.
Okay.
Well, I didn't say everybody wasn't interested. I just said some people.
I just think a lot of people don't know what they are. Like, the majority of people. So.
Yeah, they probably don't. But that's part of why we do outreach, right? So people can learn a little bit about the world around them.
This one's a different one from the beginning, right?
It's a Cirilla of some kind. I don't know.
I had
I don't
another
remember what
one.
you took a picture of, so I don't know the answer.
I'm
to that.
taking a picture.
You just want an excuse to take a picture of it.
I
It's
love
definitely different
cereal.
than-
I think it's a different one.
It's probably.
I'm just going to go back to 90 degrees.
Imanoli, I don't think that the insects get killed by the spines on a diatom. I
They're
think
too small.
most insects are monsters compared to a diatom in size, and they probably eat diatoms without considering the spines at all. However, I think I know what you're talking about, which is the in diatomaceous earth or diatomite that you can buy like a hardware store or something like that. People sprinkle it in their garden to keep bugs out and slugs out, because the little tiny broken fragments of the diatom will
Hurt them?
yeah, it destroys like ant legs. It cuts them as they walk across it, basically.
Oh my god, that I didn't know.
And also slugs harms them or snails as they try to go across them. So they'll like, sprinkle diatomite around the
That sounds a little bit aggressive.
around the garden to keep the bugs out.
Oh.
And we have some diatomite for this purpose. Like we had a bunch of ants that were creating huge colonies in our front yard, and Caroline bought some and put it out there, and it actually got rid of the ants. So
By cutting their little legs?
cutting their little legs off.
Oh my god.
Yep. So people use it in their gardens to keep out pests. Like slugs in particular really can't go over it very easily because it's, it just grinds into their
I was little
body.
mean when I was little, and I would put salt on the slugs,
You were mean.
and they dissolve.
Yeah. Salt's probably a bad combination with slugs.
Yes, I was. That's not very nice.
Well, when you're little, it's partly about,
There's a baby one here.
it's a little bit about exploration and experimentation, and you don't know what you're doing, right? To you,
Are
they're just
you
little
sure?
things.
I don't know.
To you, they're just little things. They could be robots. You know what I mean? They don't
Yeah,
have
I
any.
guess.
They don't have any we're not trained as children to look at them as having like intrinsic value. So like, my daughter used to love little ants, and then one of them bit her.
And that's
And
it.
that's it. Now, when she sees an ant, it doesn't matter where it is, she stomps on it. And it's like, you probably don't need to stomp on the ants that are outside, but she's like, ant! And then she just goes and stomps
I
on
had
it.
really bad experiences with ants when I was a little
See?
kid, so I'm with her on that one.
But if you get bit by the ant, now suddenly it went from being like a little robot to a little nasty robot that bites you, right?
That you don't want.
That you don't want. So,
Yeah.
but I think if you get older and you still stomp on every ant you see, that's
There's something weird.
wrong with you.
Yeah, I don't put salt anymore. I just disclaimer.
You stop salting the slugs, except for the ones she eats. Those ones, they put a little bit of butter and a little bit of salt, right?
No.
Yeah, we're a little psychopathic as children. It's not much you can do about it.
That's why they say children are a little bit cruel.
Yeah.
But I don't think it comes from actual cruelty. I don't know.
Yeah,
yeah.
Saturn V, it's basically like having little bits of broken glass. It's functionally what they are. Their skeletons are silica,
This
opaline
one-
silica.
That's the Carrascus
It
one?
looks like Carrascus, yeah,
Okay.
to me. It's awesome how I'm showing this on Twitch. Yeah, well, we do this twice a week on Twitch. We stream from the SEM. And then the rest of the time if I stream, it's usually light microscope stuff. And occasionally maybe a game. But mostly I don't game on Twitch. I mostly show science stuff and talk science. So kids are dangerous. They can be if you're a snail or a little bird or insects. You know. Emanuele, you're definitely speaking the language I don't speak. Is that Spanish or Italian?
Which one? Actuaciones an insectos. That's Spanish.
Acts of dehydrating insects until they are killed also cuts and pierces their exoskeleton.
Oh, there you go.
Wounding and eliminating them progressively and effectively, as you say, in a commercial product.
Yeah.
Yeah, it's okay if you speak Spanish to Laura, because she's Colombian and she understands your Spanish, but as your interloper, I cannot speak it or read it. So, and I probably would...
This one's the oblonga one?
Yes.
Okay.
And I probably would butcher the pronunciation, so I can't just read it to her. I could try. Don't expect me to roll my R's or anything. Unless I'm going to say robusta. And then I'll do
then
it.
it sounds nice.
Yeah.
Here's the lemon one again. Let's see if this one's better.
Cobalt says they're crying in Dutch. Nobody here speaks Dutch that I know of.
No. This one's pretty.
But Dutch kind of looks a little bit like English and has some words that kind of look like English to me.
I don't know anything about Dutch, so I can't say anything.
Hi, Digital Seahorse. How's it going? I think I have that emote.
Okay.
I think I have a science emote from paleontologizing. This one, and
No.
I got a yes, and I got a birds, and I got this Snakeosaurus.
It's like stickers or something?
Yeah, little emotes are like stickers. Like stickers for adults.
Are they though?
Don't tell Sukanya.
I won't.
She'll be in here getting all the emotes. Ethan says apparently a sublanguage of Dutch is most close to the English language. Yeah. I took a quick photo.
Yes.
You pulled a Mallory. Sorry, Mallory.
I didn't mean that. No, no, no.
You can just close it. Yeah.
No, I don't want to save it. There you go.
You Malloried.
Yes.
That's
But I fixed it now, so.
The diatom that we're looking at right now is Anumastus in the genus Anumastus.
That one's new to me.
Genus Anumastus, and it's probably misspelled. I can't remember if it's EU or UE. Oh, I got it right! First try! It's Anumastus, and it's probably...
How do you use... Ooh, that's pretty.
Yeah, that's
How
an
do you
SEM
spell
picture.
it?
Anumastus.
Anumastus. Okay.
It does have a little bite out of it. Probably nothing bit it. More likely, it was just manhandled.
This one's a little diatom, right?
Yes. And that one you can see the little lineolate stripe. So
Mhm.
that actually is Starosirella.
Uh-huh.
And it's probably Neopinnata,
Okay.
which people just call pinnata, but it's probably Neopinnata.
Mm-hmm.
Yep, this is probably Anumastus rostratum, something like that. Or it could be Pseudotusculus or Tusculus, but I'm guessing it's rostratum.
This one's new to me.
It's always funny how English speakers pronounce Latin names like they were English words. Well,
I do pronounce it very different, so that's why sometimes I need to ask.
Since Latin is a dead language,
You
nobody
nobody,
can tell you how it should be pronounced, and you can feel free to say whatever you like. But my colleagues from Europe always, they don't like the way that I say Eunotia. They don't like the way that I say, like, Cockanies. And any of the endings that end with "is" at the end, they always
me,
say
it's ace.
Cockanaeus.
Uh-huh. So
Which is also
coconaes.
Cockanaeus instead of Cockanies.
Uh-huh, yes.
But
And Eunotia for me it's Eunotia.
Eunotia.
So
yeah.
the T it's,
Yeah,
I don't know, stronger.
yeah. But nobody can tell you you're wrong, because they're all dead.
Diatesmis also, for me it's Diatesmis. So that's why I have to ask first, because...
But if you say it, I'll know what you mean, because I have enough friends who say it the other way.
Okay,
You know.
okay.
You don't need to change your pronunciation for my sake.
Well, I just want to get it right. Because
Mayonnaise. Hey, Pacific Plankton, welcome back. We're
so
talking
this
about
one
how to
is
pronounce Latin words.
anamo...
I left it up here.
Anumastus.
Anumastus. How would you pronounce that?
Similar, Anumastus.
Anumastus.
Yeah. That one doesn't have a lot of trouble.
Let's see. Which isn't a dialect, it's actually a language. You used to be able to speak it, but not anymore. Yeah. Nothing took a bite out of it. It just broke. Sometimes they break. Their skeletons are they're not fragile, but they're very small, and so
and things happen like.
yeah, they just get smushed or something. So, are your colleagues actually giving you a hard time about that? No. Well, yes, Itzy does, but Itzy and I are very close friends, and
So it's okay.
It's okay for her to make fun of things. For me, because we just make fun of things all the time. So, and I don't care if people make fun of the way that I say.
This one's the
something.
pseudostyrocyra, right?
Yep.
Okay, so
It's fine. Mayonnaise. People that tell Dr. Stone he's wrong all end up dead. Yes.
Oh my god.
They all do. In fact, everyone that I know will end up dead eventually.
Yes.
Except some of the diatoms I know. They may live forever.
Jellyfish do live forever. They go back to larval stages and then go back to
there is
adults
a
and
jellyfish
like that.
That's known as the immortal jellyfish that does that.
Yes.
Not all jellyfish.
But one of them.
Yeah. And it's not going to live forever. Eventually, the heat death of the universe will catch up with it. Entropy will ultimately kill it.
Get it?
Yeah, it'll get its time.
Just later than the rest of us.
Yeah, like sponges and trees.
I think this one's covered with things.
Yep, the inside's all packed full of mud. Headshot specialist, hello. The pictures I took of the moon are great. I know what you're talking about because I remember taking those pictures of the moon, and I agree with you. I did a great job on those. I mean,
Oops.
I pat myself on the back.
This
Because
one's
my
also
camera's
covered.
amazing, and it's not hard to take a picture of the moon. It doesn't go very fast. It's more or less sitting still, although it does move in my frame when I'm looking at it really closely.
What kind of camera do you have?
An Olympus OMD EM1, and I have a Mark II, and I have a Mark III.
Is it really professional, like professional level, or?
It costs about, the Mark II costs about $1,000 for the body, and the Mark III costs about $1,800 for the body.
Mm-hmm.
And then my
the lens.
lenses are very professional. There is two versions of that camera that are, well, no, there's one version of the camera that's more expensive than the one I have, made by Olympus. So the group that it would normally be lumped out with is above the hobbyist level, but below, well, maybe at the level of professional photographer.
I want to get my dad a camera, but not a professional one because he needs to learn how to do things first.
Yeah.
But I don't know what's a good place. So I think I found, no.
It's
I
about
don't
how
know.
much money you want to spend, typically.
Well, I want him to feel happy with his pictures, but it's that one, right?
Mm-hmm. Oh, I don't know if it is that one that we saw earlier, but it's close. Robusta?
We're taking a picture.
Robusta?
Yes.
Does the immortal jellyfish live forever with the same DNA makeup? The
I
immortal
think
jellyfish
so.
actually does have the same DNA makeup, and what it does is it has a larval stage and then a planktonic stage, and it can
It switches.
when it takes damage or it gets old or whatever, it will revert back to its larval stage and replant itself on the ocean floor and then make itself again as an adult. So it's all the same organism. It doesn't change DNA at all. It just keeps reverting back to the
Baby
juvenile
one.
stage and then basically re-adultifying itself, rematuring. So literally thought of as being immortal in the sense that
It doesn't die, it just goes to being a baby.
it's not it's what I would call eternal, not immortal.
Mm-hmm.
In the sense that you could eat it and then it would be dead.
Oh, yeah.
So eternal things are things that, in my mind, are things that basically can die. They just don't die, right?
Mm-hmm.
Immortal to me would be like a god or
something that can't die under any circumstances.
Impossible for it to actually die,
Uh-huh.
right? The Tick, the superhero, the Tick, right? Or something like that. That just
Uh-huh.
basically doesn't take damage, can't be killed.
Yeah, this one can be easily eaten, I think, by turtles or something.
Yeah, lots of things eat it. They probably don't like it though.
Okay, my time is up for today.
Oh yeah, you've got to go.
Yes.
Okay. That's fine.
But it's your turn to take
It's my
over.
turn.
Yes.
Now I can be on the camera for a little bit. And it's good because
Bye,
Pacific
Twitch
Plankton is back.
streamers.
Yeah, they're all probably happy to have met you again, or for the first time. Now you have to go out into the outside world with a mask.
With a mask.
on.
Yes. Bye.
Have fun, and I'll see you in
In a
an
little
hour
bit. Yes.
when your presentation is. Don't forget your coffee cup.
Sorry?
Your coffee cup was here
Oh,
somewhere.
it's here.
Okay.
I have it.
Thank you, Laura.
Bye. Thank you.
And I can kind of keep my chat window open over here so I can half manage it. Does it multiply? Yes, it does. It's basically cheating death. Yes. Does it have brains? No. It's a jellyfish, so I don't think they have brains. And hello, Dangling. That was Laura, my graduate student. She started working with me this semester. She's from Columbia. And I think this camera is all pointed up towards the top of the sky, so. Now it's chopping off my head a little bit. Probably better. Okay. Yeah. Biologically immortal. Yeah, that's usually what we call it. So Laura, it's finals week here, and that means I have almost nothing to do, and students have a lot to do still. So Laura is in a class called Microfossils, where they had a project, an archaeological project for the semester, and they're doing a presentation, an in-person presentation. I think it's a poster that they had made from the project that they developed, and she's working on that presentation for the next hour or so. I think the poster's already together. I think it's a virtual poster, but they're presenting it in person. So like the whole thing will be up, and then they'll just sort of move around on it. I think this is Pseudostarosira robusta. Internal view. And so I have like an hour where I don't have anything to do, but I do need to eat lunch. Because it's like 3 o'clock, and if I don't eat lunch sometime in the next half hour or so, I'll have to go till dinner time, having only had breakfast, which I do sometimes, but if I don't get over there probably soon, all of the restaurants will be closed, and then I'll have to walk farther and potentially not get good food. So I'll probably end the stream in about 15 minutes or so. Just want to do a little bit looking around. We never left the same sample. Laura's been just looking around on one sample the whole time, even though you can see below there's 7 stubs in our actual SEM chamber right now. And that's normal when we're looking at diatoms, really. There's so much to see that unless you force yourself to go to another stub, or unless your stub just doesn't have anything on it, we usually end up looking basically just at 1. And I still always make 7 or put 7 in there, thinking maybe some of them won't have stuff on them. But they usually have a bunch of cool stuff on them, so we end up basically just sticking in with 1 sample the whole time. There's lots to see, though, so it's not like we ran out of things to see. This is a really nice, almost completely clean Lindavia intermedia. The external view, it's just got a little bit of clay on it, and right now it's slightly out of focus. That's a lot better. You can see there's sort of larger holes and smaller holes here, and then even bigger holes over here. I'm going to zoom in even a little bit closer so that we are really high magnification. We're now at 152,000 times magnification. And earlier when Laura was trying to get the SEM focus perfect, we were tweaking the settings a little bit, and it's hard for somebody who's new to figure out, but it's pretty easy for me to do. And so I was sort of letting her try to do her best. And then we got to the stigmation, and I was kind of like, well, let's not spend too much time on it, just because it'll take a little while. But now that she's gone, and I can spend a little bit of time on it, you can see that's worse. And if I turn this, I can kind of get it to go better usually. Actually, I need to turn the step up a little bit. I'm just going to tweak a little bit. Hopefully it'll be worth it. So a little bit of patience usually goes a long ways in the SEM later on. Somewhere in here. Somewhere in here. So normally also if I'm doing this, I will decrease the beam intensity even farther so I can get a little bit better clarity on my image. Sorry, that's the beam intensity that I'm twisting right now unintentionally. And what I'm doing is just called stigmation. It's like putting glasses on the SEM. And as a result, our 200,000 times magnification image is now in focus. And like perfectly in focus. And so the farther I zoom out, it stays in focus. And that's nice. I can change the beam intensity to go back up a little bit because I'm starting to zoom away from that tiny, tiny scale to a much larger scale. And now that the stigmation is where we want it, so I did that at 200,000 times magnification, but now we're zoomed way out. So we didn't need all that detail to take this picture, which is where we've been mostly taking pictures with Laura, but if we were trying to zoom in on some features, that would be really useful to have it corrected at the get-go. And now I just need to lower the speed of the beam, and you'll see all of the detail of the image we were looking at. The other thing Laura wasn't doing that I normally do is reset the brightness and contrast a bit. So sorry, it's hard for me to keep up with the... I don't think she can, Ivan. You missed a Spanish speaker, yeah. She didn't do any Spanish speaking, so you didn't miss much. All this is making you want to sign up for a degree in biology. It's not a terrible idea. I'm not a biologist, by the way, I'm a geologist. But I do pretend to know a lot about biology. So, it's making you hungry? You want to eat some of these? how did we take the samples? These samples were collected with a surface sampler from a boat by Dr. Mike McGlew. So because we're going to be ending the stream soon, I just want to have one nice clean picture with this external view here. And as a result, I'm going to slow the beam down even further to an 8. And you can actually see a little bit of that transition to a slightly higher quality image right here, as it loses some of the noise from that image. And we'll set that. I got this. Actually can lower the beam intensity just a little bit to a 6 to make it a little bit more clear, even from where we are. So you can see that really sharp image now, and it's more or less where I want it. And I'm just going to hit that button, and that's it. We got a 10-minute wait, so I can catch up with chat a little bit, and then we'll find somebody to raid. Super zoomed, yeah. Thank you for the shout out for Devil and Mrs. J. Her thing is Mrs. J, like that, and then it just gives you the details. This is a beautiful picture. Thank you. It's going to turn out really nice, I think. Okay, so you know, it's time to say farewell. Basically, we got about 5 minutes left before I wanted to end the stream, go get some lunch, and then get ready for watching that the presentation the students are going to do. And as a result, we should go raid somebody. And lots of cool choices for us to raid right now. Lots of friends of the channel are on, and I will maybe let you guys decide who you think we should raid. I've got people in art, people in science and technology, and people in music. So pick one of those, and I'll just go with whoever says stuff first. And then that'll narrow it down to just a couple of people, and then we'll go on and raid from there. So, art. Okay, thank you, Digital Seahorse. So my choices in art are Estorella, who started streaming a little bit earlier today, before I was streaming, actually, and I was in there hanging out with her. So maybe raiding her would be a good idea. And then there's Bassinia Designs, who is also part of the artist community that I hang out with, the Artist Back Alley. People who, so she's a really cool artist, does a really cool, amazing, and very quick at what she does. So we can just, I'll pick one of those. Let me see what Estorella is up to. I don't want to raid her. She's ending her stream. So I've got to see what they're working on right now. But it would be nice to go visit Estorella and see what she's working on. It looks like she's in the middle of something. So why don't we go raid her? She's a mostly digital artist, I think, and a really, really nice person. So a good person for us to raid, potentially. Okay, so hang on to your shoes. And I just want to say thanks to people for hanging out with us. It's really nice to get a chance to do some of this with people. Have interactions with you, and also for entertaining me while we're watching mostly Laura do work on the SEM. We had follows from Scoop Them Cookies, Ernst, Luke Was My Dog, Regular Cobalt Ethan, who also was chatting with us quite a bit in the channel. Which one has the least viewers? I think actually Estorella probably has fewer viewers. So if you're trying to balance things out for her, that's a good choice. Also, I don't think I've ever raided her, so that's another good thing. I do a lot of raids for the other people that were in that list of potential people to raid. So super, super sweet person, and she does really cool digital art, and was really generous. When I was in there earlier, she was showcasing some of my SEM work and Instagram work. So I'm actually really happy that that's who we ended up picking to raid. Okay, so we'll be back on from the SEM next Monday, probably around 2 o'clock. And then next Wednesday as well. So probably looking at Diatom stuff again. We might be back into looking at some of the samples that Pacific Plankton sent me. And also want to give a thanks to Pacific Plankton. If you don't know who she is, you should be following her as well. So she'll be streaming tomorrow night from her science fort at her house, and at midnight Eastern time. I don't know if you're on Eastern time. What's Monday at 2? Oh yeah, that's when I'm going to stream next, yeah. And I think Del Maximum, who was in here also talking about streaming from his microscope, will be on tonight, usually around midnight or something like that. Oh, you're going to have the wrist cam on. Great. So we can see whatever bracelets that she's wearing. I guess we're rating now. Perfect.